So a little bit about me. My name is Robert Ross. People like to actually call me Bobby Tables if you're familiar with the XKCD comic. I'm at Bobby Tables, GitHub Bobby Tables, all across the board. I'm a software engineer at Namely. I'm also a huge marching band nerd. Yeah, I guess this is the typical audience for marching band nerds, so that's good. So here's my proof. I am an adult in this photo. That's the other weird thing about me in marching band. But lately, I'm actually an Istio nerd. So this is actually just a really quick kind of story about Namely and how we picked Istio to start using it for development needs and kind of streamline and really integrate our services a lot faster. So a little bit about our company. We are an HR payroll benefits company. We move about $1 billion in payroll a month. We are about 100 engineering employees about in our department. And we have the early beginnings of a microservices architecture. Early beginnings is kind of I should really say we have a small amount of microservices. We tried doing microservices. We've been early beginnings for about 2.5 years now. So our infrastructure, right now we are rolling with Kubernetes 1.9. We use Jenkins for tests. We do use Spinnaker 1.8 for deployments to Kubernetes. We use Amazon Web Services for all of our infrastructure, 4 environments: integration, staging, development, and ops. We use Istio 0.8, and we're using gRPC for all service-to-service communication. This is a company-wide policy. And we are a multiple language shop as well. So we have a lot of Go, a lot of Ruby, C#. We are using .NET Core on Kubernetes, and we are also using Python for a lot of our internal services as well. So looking back, we had 2 services, and now we have too many. So we had 2 services, a Rails monolith, which we still have, and a .NET monolith. Now we have 36 and climbing services in our architecture. And we also found ourselves with the common problem that once a lot of companies started going to microservices, they realized that, oh, this is actually a lot harder to develop on. So we kind of had this, we had to really actively think, how do we improve our developers' lives? Because it causes a lot of problems when you don't have the right development environment. It can slow down productivity. People just get mad. If it's hard for a person to work, they will leave your company. Engineers are still running 10 services locally to develop. Anyone run Docker Compose locally? Does anyone have a really good computer fan that's just working way too hard when they're running Docker Compose locally? Yeah, a few hands here, right? And engineers are potentially integrating with out-of-date services. You have to ask basically engineers to run a Docker pull all the time if they're integrating against services to make sure that it's properly up to date, right? Because while gRPC and protocol buffers offer a somewhat guarantee that you have a backwards compatibility, it doesn't guarantee business logic. So you have to make sure you're constantly hitting a service the most up to date. So I'm going to give you a scenario here. Ellen, the engineer, is working on a service that requires another gRPC service. She's running a gRPC service that she depends on locally to develop. So she's running the thing that she's working on and the thing that she is developing against. She pushes her changes to an integration environment, but her service suddenly just doesn't work anymore because it just doesn't work with their third-party service. That gRPC service she was developing with just got out of date. Some other team owns that service, and they pushed up a change, and it just broke everything. She doesn't know until she pushes to a full-blown cluster. The 2 most important bullet points in here, though, are the last 2. She pushed a change at the last minute, and then it broke. This is a problem because now you have to context switch. What if that small change that you were integrating with, you did a week ago? Now you have to go back a week in time in your mind, and you have to remember, OK, why could I possibly have broken this all of a sudden? And that reduces the amount of time that or increases the amount of time before something actually gets out to production. So you're losing value. So the problem here is that you're making sure that your services are playing nicely together. It's a very, very difficult problem. It's especially true when they're all changing all the time. This problem is more prominent for local development because you just can't run everything locally. Your computers really have a limited amount of CPU and memory. If you have a service stack that has 20 plus, your local machine just can't run that many services effectively, especially if you have Slack on your computer because that just eats up an entire core and you have no option. And really, we don't want our computers to become George Foreman grills. I was super curious, what if I type in egg on a laptop cooking? Sure enough, this exists, and it happens to be an Apple laptop, so thank you, Google. So how do we solve this? Where does Istio kind of come into this as a solution? We wanted to be able to allow our engineers to write their software locally. Rule number 1. But the service that they rely on were in the Kubernetes cluster. That was the other thing that we wanted to allow our engineers to do. The things that they are integrating with are running in a cluster that SRE manages and is constantly up to date, has no production drift. Engineers are allowed to connect to these services from their local machines and develop against them. They're able to do this, however, this was the tricky part that Istio solved for us. How do you do this without interfering with other people's work in that cluster? How do I deploy my service to a cluster without touching somebody else's work? If we're both relying on a service and I need to touch it and try to make sure it integrates well, how do I make sure I don't mess with you? So to get into that, I have to explain a little bit of our routing. It's pretty simple. We use wildcard subdomains for all of our routing. Namely is a B2B business. So if you are a client of Namely, you get a subdomain. You'll be, let's say, huli.namely.com. That could be a potential subdomain. And it's also the same story for our integration environment. So it's huli.i.namely.com in a private DNS zone. So this subdomain is actually really important because it allows us, we can use this subdomain as a trick to actually create Istio virtual services that route specifically for a developer's environment. So this is kind of how we're going to start to go down this request stack. So the Istio request cycle with Namely is we do have a request that comes in. We are using Amazon, so we have an AWS ELB, receives the request, and then that goes into the Kubernetes cluster, which eventually hits the Istio ingress gateway. And then the way that we have our gateways configured, very similar to the previous talk for Cloud Foundry, we are routing everything star.i.namely.com, and we are routing it, and we're opening up port 80 for this. So in the way that we actually segment all of our gateways, we run multiple Istio gateways, is we use the TLD of the domain that gateway actually receives. So we can actually scale them up independently based on the TLD. So now that we have this gateway, we can actually start attaching Istio virtual services to this gateway to start routing traffic effectively. So our stack starts to look like this. We have many what I call edge services. So we have Bifrost Web, which is our authentication. And then we have HCM, which is human capital management, which is a gigantic Rails monolith that we've had for years. And what we do is we attach this Istio virtual service to this ingress gateway. And it can actually start routing traffic just to Bifrost or the Rails app based on path matching rules. So the path matching rules that we have here are the user's login in Bifrost Web. And then if you're on the /people endpoint, which is the company directory in our software, it actually goes to HCM Web. So keep this in mind on how this looks right here, because it's going to change in a few seconds here. Because everything I've talked about, you've seen today several times. So how does this actually help developers? Dramatic pause. Namely's platform control is actually where we started tying this in. This is a CLI that we've written. It's all written in Go. And we actually use it to communicate with another service that we've built called the Workspace or gRPC API. And what it does, it actually creates a workspace inside of the integration Kubernetes environment. And what we do is every application actually has this Namely file, which is just a simple YAML file that describes how the application boots. It starts the project locally, and then what it can do is it actually swaps the deployment in that int cluster to point to you to route all traffic down to your local machine. And I have graphs. So this is a Namely file, because we do have some applications that are monorepos, where they are spinning up different types of containers. So if you have worked with Docker Compose, straight out of Docker Compose, we were like, we're not going to reinvent this. Let's just steal the same format, minus we're going to define we're going to call it projects. So we do have a name, my app. It does describe exactly how a Docker file would actually spin up this application, volumes, ports, the whole 9 yards. So platform control uses this file to actually spin it up locally. But then the next thing it does is actually hit something called the Workspacer, which is running in a Kubernetes environment. And this is the thing that actually communicates with Istio and its API. So it's a Go gRPC service in the integration cluster where Istio is installed. It receives requests to create workspaces, as we call them, for the engineers that are trying to create, to try to integrate with other services. What it does is it actually copies the resource that exists in the integration cluster that you are working on. So if you imagine you have a deployment, a pod running in an integration cluster, and you're working on, let's say, the Rails app, it's actually going to copy that deployment that's relevant for your application you're working on locally and scale it down to like one replica and change the name of it and actually create a new Istio virtual service. So if I'm on my local machine, what I would do is I would type in platform control proxy my app. And what this is going to do, as I said, generates a gRPC request and sends it to the Workspacer API. What it does then is it's actually going to start a local Docker container using that namely file that kind of describes the runtime environment of that application. Then what it's going to do is it's actually going to swap your container running locally for the container that it just copied up in the integration environment. And there's a tool that we use this that I'll detail in a second. On the other side of this, Workspacer gRPC copies the service and the deployment because a lot of our services are not, they receive requests. So it'll actually copy the Kubernetes service endpoint and the deployment. So in the environment, you get a whole new pod and a whole new service name. But nothing is going to route to that because the ingress gateway just knows about that one vertical. So we have this slide. This is what we saw a little bit earlier. So now imagine that I've run this proxy my app command. What's going to happen is it's going to copy that HCM web deployment, and it's going to prefix it with my username. So every engineer at Namely has an internal username. And you're going to set all the replicas down to 1. Engineers don't need multiple replicas when they're working locally. The next thing that it's going to do is it's going to create a new virtual service and attach it to this Istio ingress gateway. What it does from here, and I'm so proud of this, by the way. This slide just gets crazy. Oh, I lied to you. It's up soon, though. So how does traffic, that's how excited I am for it. So how does traffic get to the local container then? This is great. All we did was copy a deployment, and I started a container locally. No magic has happened yet. So we are using a tool from a company called DataWire. They have built something called telepresence. And this is how they describe it. It is fast local development for Kubernetes and OpenShift microservices. Really, really cool project, open source. What this actually allows us to do is replace a Kubernetes deployment with a locally running Docker container. What that Docker container transparently gets when using telepresence is it gets all of the network requests to the container in your Kubernetes environment actually sent down to you. So if I do a curl request in my Kubernetes environment to the container that I have swapped, my local Docker container is going to be the one that receives that request. So this is what starts to happen. Are you ready? That's not it. This is it. OK, so here's what's going to happen. I run telepresence, and we have our copied HCM web container and pod running up there. What's going to happen is telepresence is going to start that local container using that namely file definition that we've actually set up. And it's going to start actually proxying all the requests down to my local machine. So now the container that I had up in int is now been hijacked by telepresence and sending everything to me. So if I'm changing a view locally for this Rails app, I can actually go to bobbytables.i.namely.com, refresh the page, and see my change. But if I go to huli.i.namely.com, I'm not going to see that change. And that's all because platform control hits this Workspacer API, copies the deployment, and it creates that Istio virtual service. Because that Istio virtual service, because we route on star.i.namely.com, we just duplicated virtual service and just replaced the star with Bobby Tables. And then instead of sending it to HCM Web, we send it to bobbytables-hcm-web. And that's kind of why we're able to federate, like, oh, your subdomain just gets this Rails container over here. It gets all the same container config and everything from the Kubernetes cluster as well. So now an engineer, they can work within the local container. They can see changes live. And they can hit services from their local container, because what I forgot to kind of mention that is really impressive about all this is that I can make requests to services from my local machine as if I was in the Kubernetes environment. So if, let's say, I need to hit a session service, which is a gRPC service, I no longer need to run sessions locally. Because telepresence has kind of hijacked my network, if I do sessions.applications.svc.cluster.local, it's actually going to go up into the Kubernetes environment. So that means that I'm integrating as quickly as possible. If I'm refreshing a page that relies on a gRPC service, I don't need to run it locally. So I'm very, very confident that what I have built is going to work with services already in the integration environment, which is deployed all the time. So what about non-edge services, though? Because I'm sure that a lot of us have services that don't have views. They don't sit under the ingress gateway. It's ingress gateway and then an application talking to this other service. So what do we do in those cases? Well, so what we do for that is we actually tag all of requests coming into our cluster with X namely company permalink header. And the reason this is important is because it's a rule at namely that your service must propagate this header through all of its gRPC metadata calls. And similar to open tracing or Jaeger tracing headers, if you're familiar with those. And what we can do then is we can actually create an Istio virtual service that routes strictly on this header to a copied, proxied one using the same exact workflow we did prior. So now our graph starts to look like this. Let's say that I am actually working on the sessions service, which is another gRPC service at namely. We actually create the workspace virtual service, and that actually gets tied to all of the containers in the mesh. And if anything comes in to the Rails app, because we're propagating that header, Istio and Envoy is going to realize and say, oh, this is created for bobbytables.i.namely.com. I'm actually going to forward only this gRPC call to the sessions one that you are currently proxying. And that's really cool if you think about it, because if somebody else is working on, again, huli.i.namely.com, and I break session service, I just push out something, it's panicking, it's doing something wild, what's going to happen is it's not going to break anything. Because it's not even going to get sent to my session service. It's going to get sent strictly to the other ones, which is great. It's a big win, right? I don't step on any other engineer's toes. Only my session service is going to break my domain. And this is the way that this actually looks. So the workspacer API, it's actually using the Istio model. It's generating this YAML config, and it's actually applying it to the integration cluster. So the mesh config, again, it's going to see this match on the header, exact Bobby tables, and then just forward that straight to the sessions gRPC service. Nothing else will match on this. So what did we accomplish here? So Ellen can now develop her services locally, almost the same way, without having to run a bunch of other services locally. This ensures that whatever she's developing is hitting the most up-to-date version of the service. So at namely, we actually deploy all services on master merges. So on the integration environment, if you're proxying up to that integration environment, you're hitting the most up-to-date version of that service. And this goes the other way as well, if you think about it, because let's say that you push a change out that botches a bunch of other services, you're going to know very, very quickly if mine all of a sudden starts breaking against your service. Other engineers can use the same technique without stepping on each other's toes. We can have 10 engineers doing this and 10 virtual services for 10 different subdomains. And if QA wants to hit just that subdomain to try just that change, we don't need to deploy an entirely new Kubernetes cluster. We can deploy a Rails app just to that subdomain running locally for a QA engineer to go in and very, very quickly try this out. Or the QA engineer can even try it locally. Because we've simplified the way that the application runs locally, it's not difficult to get engineers running the stack on their machines hard. It's not hard at all. So that's another really big win of this. And also, it just improves efficiency. We're operating a lot faster. We can very quickly test something in the cluster, tear it down, and then go back to working locally without having to proxy all the time. If you had like Caltrain or the subway or whatever you're doing, you can't do this, right? So we have to offer the ability to run everything locally still, which is something I would like to get rid of. Maybe we'll start to invest on just heavier machines that can run the whole stack, but TBD. So that is what I have for you. These are my handles. Bobby tables pretty much anywhere. Please don't look at my Pinterest. And then robert@creativequeries.com. It's just, I don't know how to tell people what I like for my hair, so I just go on, that's the only thing I use. We don't need to go into it. So this is pretty cool, right? Obviously, required namely.com/careers. Any questions?
So before we start, like, his name is Bobby Tables, and I was like, well, what's my rap name? And where does Bobby Tables come from? So I Googled, okay? So I had to Google this. Everyone know where Bobby Tables comes from? Have everyone seen this comic? Don't fake it if you haven't seen it. Raise your hand if you haven't seen it. We're going to see it.
Are we doing this?
You got to do this, and you're going to read it out. We're going to role play.
You want, oh.
Yeah.
Are you the mom or am I the?
Yeah, pull it up.
Right.
Let's role play.
All right, we'll do the 20 seconds of awkward silence, whatever. Or you want to read? You the mom, am I the kid?
You read both.
All right.
And you gotta use the right voices too.
Hello, this is your son's school. We're having some computer trouble. Oh dear, did you break something? In a way. Is your son really named Robert Drop Table Students? Oh yes, little Bobby Tables we call him. Well, we just lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs.
Bobby Tables.
Thanks for doing that.
Yeah, you're welcome.
All right, any questions for MC Bobby Tables? We'll start with you.
Thank you, MC of the MCs. So this was super rad. My one question is, when you are running those dev environments within int, is it only doing read requests on other services? Or could it possibly do writes?
Yeah, okay, so I knew this would come up. I figured it'd be in the first or one or two questions. So yes, you can totally mess up the environment because you have write access as well. We are not preventing writes from happening. So because we are kind of a, tenanted database because of the subdomains on the companies, we're not as worried as people just totally botching things. However, that doesn't mean that you can't run rigdb drop and ruin the whole thing. So we actually do have automation. The integration cluster is actually refreshed every single night. So we actually have an obfuscation process that takes things from production, changes names, socials, and everything, and then actually loads that onto int. And that's actually a Jenkins job that we run on a cron. So if something does go just horribly wrong for any of the databases that we are running, we can run that Jenkins job, and in a few minutes we can actually have a new, we'll totally fix it really quickly. So we have very actively accepted the risk that somebody can ruin data with this workflow.
So kind of adding on to that question, I saw a similar talk by the folks at Buoyant for Linkerd stuff, where they do in production integration testing, whatever you want to call it. And one thing they said was it forwards so you have that X, namely whatever thing. I'm assuming this service also passes that along to its downstream, right?
Correct, yeah. So it is a rule that all services that are making service calls must attach that header to the gRPC metadata. Because once you're inside of our cluster HTTP, we have a company policy that everything is gRPC. So we actually have tools for all of our languages that will propagate that header along with open tracing headers, which we are also using with Istio, but I did not mention that.
Do you propagate a test header, anything coming from this service is trash, don't believe it kind of thing for?
I don't follow, actually. What would be a header that would?
So do you send this is a local service, it's not in the cluster, don't accept a drop table command from it kind of thing?
Oh, no.
No. Okay.
It's Bobby Tables, baby. Oh, it's refreshed. It is. Okay, refreshed.
Yep. Yeah.
So just on that question, I think you can also use Istio policies to restrict the access from experimental services or developer services. So even if they try to do these actions, they won't be allowed. Have you tried doing that?
Yeah, so we haven't considered that. The Workspacer has actually gone through a lot of growing pains. I have every folder of Istio that I've been working against to try to keep Workspacer up to date. So we haven't spread it we haven't integrated 100% with all those Istio capabilities because we do know that the APIs are changing and evolving. So just the virtual services and gateways being split out of the route rules from 0.6 was enough challenge for us to not consider doing anything else yet.
So when I think of developing applications, usually what I think of is a separate dev environment and a separate production environment. And this seems like it's a cool feature, but maybe a lot of overhead and a lot of expertise is needed to run it. So I'm wondering if you see that there's significant advantage to this method, or if I'm misunderstanding something along the way.
Yeah, so this is a good question. Here's the way I think of it. I think of Istio, Kubernetes, Spinnaker. These are tools that are puppets, and it's up to engineers to be the puppeteers. So we're responsible for kind of creating the ways that we want to interact with these tools. And that was the first iteration for us was the namely file. Engineers don't need to know anything else about the infrastructure except for the namely file. And if we keep these abstractions for engineers very, very small, they don't need to concern themselves, and they get to focus on what they come into work and what we want them to do, which is business functionality. Another great example is we basically define your pipelines to deploy these projects. We we generate YAML files automatically for your Kubernetes environment. So I don't know if that kind of like answers your question, but the overhead for us is more educating on how we, like the process that we've created. Istio is Legos, and we're the instruction manual.
Yeah, I have this saying, everybody wants a pass, but the only caveat is they have to build it themselves.
Yeah.
All right, because there's lots of opinions that come with the ones out of the box. We have one last question, and it's time for our 30-minute break.
Is Workspacer tightly coupled to Namely's way of working, or is it something that could potentially be open sourced and added to the ecosystem?
I'm considering it for open source. I've been trying to write commits that are not embarrassing for when we do push it out. The one thing that we didn't talk about in here is how it authenticates. So we are using JOT tokens that are issued to every engineer. So we have one place that we've signed them, and that's how we're authenticating platform control requests to the Workspacer. So we would have to figure out, like, how do we want to authenticate this? Do we want to use like RBAC rules in Kubernetes, or use those same type? Do you apply a CRD that people have like access to instead of hitting a gRPC service directly? I think that communication layer from machine to Workspacer is what we would have to iron out before open sourcing it. But the logic for Workspacer to Istio is very, very open sourceable.
Awesome. So, hey, we got another break coming up. So 30 minutes, and then we'll be back here. Big round of applause for DJ Bobby Tables.